Let's graph some polynomial functions, and when we do, it's going to be one of those conversations where we begin to start picking apart the different aspects of how a graph is related to the equation and what we can find from that. So let's start by finding and plotting the x-intercepts of this. We already know this, I hope, but if we're going to find an x-intercept, then y is equal to 0. So for example, if I'm sitting down here on the x-axis, I have an x-intercept randomly there, just picking a point. That coordinate is 2, 0, which means the y equals 0. So when I do this, I'm going to say, well, y equals 0. Well, the y is the f of x part. So 0 equals x squared minus 2x minus 8. And then we'll solve it. Well, because it's quadratic, we can factor, well, this one does. We could use a quadratic formula if we wanted, choose not to. Two numbers multiply to give me 8. It would be 4 times 2. We're multiplying to get a negative 8, so it's negative 4 and positive 2. So negative 4 plus 2 gives me the negative 2 there. So x minus 4 equals 0. So x equals 4. X plus 2 equals 0. So x equals negative 2. We have just found the x-intercepts of this. So what we're going to do is plot them. I'm going to plot them in red just to make them stand out. So x equals 4. 1, 2, 3, 4. And x equals negative 2. We have two x-intercepts. And just to be really technical about this, I'm going to write the final answer in red over here, and I'm going to write it as a coordinate 4, 0 and negative 2, 0. So when we find and plot the y-intercept, well, here's what we're going to do. We're going to say x equals 0, and this becomes pretty easy. So we're going to say, well, f of x equals, well, 0 squared. I'm looking up here and plugging in zeros for x, minus 2 times 0 minus 8. Well, 0 minus 0 minus 8 is negative 8. So final answer on this one is 0, comma, negative 8. So we'll plot that. We're going to go 1, 2, 3, 4, 5, 6, 7, and we're off the graph. That's okay. It's down here, about there somewhere. There it is. And we're going to sketch a graph. It doesn't have to be perfect. We could talk about where the vertex of this is, and we're not. But let me just point out something that's always true of every quadratic. The vertex, and when I say vertex, I mean it's the point where it turns, like it's its maximum, like there, or its minimum, like there. When I'm talking about a vertex, it's always going to be halfway in between the x-intercepts. So halfway in between, it's going to be right there. So I find the halfway point between those. There it is right there. So the graph of this thing is going to look something like this. It's a parabola. It comes down. Whoops, I'm about to miss that y-intercept there. It does that. I'm drawing it way too big, way too wide, I guess. But it turns here, and that's going to become important as we answer another question. And I might be missing many of the other points of this, not conceptual points, but actual coordinates. But it's something like that, okay? And the vertex, I didn't draw it exactly right, but the vertex is down here, wherever that is, but it is at 1, comma something. And I know it's at 1, comma something, because 1 is halfway in between negative 2 and positive 4. So where it says, where is f of x increasing, excuse me, I want to know where this function is going up. So let's just trace it for a second. Going down, going down, going down, going down, going down, turn, going up, going up, going up, going up. So where was it going up? And when I say where, I mean at what x values? Well, from this x value onward, the graph was increasing, and that was from 1 onward. So we're going to say that it starts at 1 and it goes to infinity onward. So it's going up forever. And we'll put a parenthesis on that. Mathematicians can argue over whether or not this is a parenthesis or a bracket. I'm going to call it a parenthesis because technically at 1 it is neither decreasing nor increasing, but that's my opinion. Where is f of x decreasing? Well, going down, going down, going down, going down, right there. So it's going down all the way to there, and there is also at x equals 1. So from negative infinity to 1, the graph is decreasing. And then we get to some of the more basic questions about this that really don't require as much thought. It just requires an understanding of the definition. So what is the degree? And that is the highest exponent. We have encountered that before. Highest exponent of f of x? Well, it's a 2, so that answers that. The degree is 2. What is the leading coefficient? And that's going to be the coefficient that is in front of the term that has the highest exponent. So I'll write that down. So coefficient in front of highest exponent. And there are exceptions to that. It needs to be in standard form or some sort of form where it's written as a polynomial. Like if it was in vertex form, then it may not be as easily identifiable. Maybe it would, maybe it wouldn't, but things would be jumbled a little bit. Nevertheless, my leading coefficient in this case is 1. And then we come across this weird definition, end behavior, and don't make it harder than it is. When you look at this graph, what is it doing? Well, it goes down and then back up. But if I looked at both sides, what's the left side doing? Going up. Let's draw arrows. What's the right side doing? It's going up. So my end behavior is up, up. And that's going to become important because if we start looking at these and trying to figure out how to graph it, we can look at certain aspects of the equation and figure out if it's up, up, or down, down, or up, down, or down, up, things like that. Just kind of makes it convenient to glance at it and really tell what it's doing at the end of the function, at the extreme ends of the graph. So we're going to do the same thing for this one. We're going to find and plot the x-intercepts of that. We've used g this time. And we'll do the same idea. So y equals 0. So 0 equals negative x squared minus 5x minus 6. Let's do something wild and crazy. I don't like that negative in the front. We're going to divide everything by negative 1. And that's 0 equals positive x squared plus 5x plus 6. We'll factor that. This is x plus 2 and x plus 3. So final answers, x equals negative 2 and negative 3, and actually real final answers, I'm going to write it as a coordinate, negative 2 comma 0, negative 3 comma 0, and we'll plot them over here. So negative 2, negative 3. I'll go ahead and tell you the vertex is halfway in between them. So the vertex is going to be at negative 2.5. So find and plot the y-intercept. This part's easy, actually. A lot of people can do this in their head, and you can too. You'll be able to in just the next few seconds. If I plugged in 0 here and here, both of those terms would be gone, and I'd be left with a negative 6. If you want to show the work, you could say, well, negative 0 squared minus 5 times 0 minus 6. Well, that's just negative 6. So my y-intercept is 0, negative 6. So 1, 2, 3, 4, 5, 6. There it is. And we're going to sketch a graph of this, and it is a parabola, and so it comes up like this, and then it turns around. That looks like a ghost. It does not look like a parabola. It is shaped all kinds of wrong. Its concavity is not correct. That's kind of a calculus phrase there. I had its concavity wrong. I'm trying to hit this point right here, and there we go. That's not too much better, but slightly better. Anyway, where is it increasing? Well, increasing, 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 increasing until it gets to here, and here is halfway between negative 3 and negative 2. So it is increasing from negative infinity to negative 2.5. It is decreasing from negative 2.5 to infinity. So increasing, decreasing. And then easy questions. What's the degree? Highest exponent I see is a 2. What is the leading coefficient? Well, that degree of 2 had a leading coefficient of negative, understood 1. Describe the end behavior. Well, if I drew arrows, which direction would I draw them? Assuming I drew my parabola correctly, and I didn't exactly. I don't have too much symmetry going on here, but that's okay. End behavior would be down, down.